Since we're early, I'll share a brief Svar Torah. I think it's nice. This many Jews are still walking in the door. It's Matos Masai, the Shabbos Matot Masai. Heard a very beautiful vort, under 60 seconds from Rav Twersky, Abraham J. Dr. Rabbi Abraham J. Twersky. On Masai, it says, I just lost it, but that they traveled from Sukkot to this place, and then from this place to this place. Meaning the structure is from A to B, and then from B to C, and then from C to D. It doesn't say they went from A to B, and then they went to C, and then they went to D. It actually repeats the place, and we know that the Torah is very scarce with its words. Why would the Torah waste words? And it's not wasting at all. It lets you know that even though there was really nothing to see in Sukkot, there was really nothing to see in the middle of the desert. They just stayed there because they were being punished, really, but they had to be in the place while they were there. They weren't just passing through. Even though there was an ultimate goal, there was an ultimate destination, that wasn't the point. They had to be where they were at the moment where they were, and we have to be where we are in the moment we are. We have a goal in mind. We have a destination in mind. There's somewhere we're supposed to go. There's somewhere where we want to be eventually. We're not there yet, but our purpose right now is to be where we are now. And if we miss that, it's not going to matter if we get to the destination, because we won't have arrived with all of the tools that we were supposed to develop along the way. So a lot of people in this country, on this call, in the world right now are going through a difficult time. It's easy to think, I can't wait to see the other side. But the truth is, we are where we are right now because that's where we're supposed to be. That's the first thing. The second thing is next week, mark your calendar. We're doing another panel. Back to popular demand, this time on interviewing. We're going to have some great panelists. Please mark your calendar. Please tell your friends. And the third thing, we're so thankful to Cardknox and to Fidelity. We're very excited to hear from Yanky Weiss on high availability deployments. You can share your screen again. Yanky Weiss is the CTO of Cardknox and Fidelity. Without further ado,
okay, thank you for the opportunity. So, as a lead on Lahavdalim during the Kodesh L'Chel, we're going to try to show the journey of, a possible journey on how to get to high availability deployments. Obviously, and most people don't start or don't have always the need or the amount of effort to build out that castle to get to fully high availability. Even while deploying, and so we'll start. How most of the time it starts somewhere with a single server, kind of manual deployment, whatever way you're deploying, either by logging into a server and popping in some files, or maybe pushing it through some tooling, and then if something goes wrong. You have to roll back, and usually you might have to compile, even redeploy. Might have to fix the problem, and redeploying is when it's down, you have the issues, and we'll kind of describe the issues at that stage of the game. So you have a single server, so you have a single point of failure, obviously. When you're deploying, your server's down for X seconds during deployment. It might depend on what language and servers are using. But at the end of the day, if there's some hiccup you're gonna get. You might lose one connection, or you might lose 30 seconds, 60 seconds, depending what you're doing. I'm getting some echo, so if you want to mute, I don't know if you want to mute everybody or. Additionally, even though you can test your deployment and locally, or you might have some stage server or dev server or whatever you have, you cannot test in your live environment, and there might be differences in your live environment. Again, it depends on what language you're using, if it's compiled, not compiled. You might be missing a file. You might it might be a permission issue. There might be there might be something that happens after deploy, or deployment itself might fail, and you can't test it before deploying, before getting it into live. And if ultimately something does fail, whether it's just a code bug, a deployment issue, it's down, until you fix the problem, redeploy or revert, maybe to previous, to the previous good copy in code, recompile possibly, and then redeploy or kind of republish. And that's more or less the picture of an early stage product or server. So one of the first things to attack would be, and a lot of this is based on kind of personal experience with different products, but I'm sure some of these things will resonate with a lot of you. So solving the single server problem is relatively easy, depending how deep some problems are. But multiple servers is, especially with today's cloud, is not so hard. Stick a load balancer in front of it. If your code is not designed for deal with multiple servers, your load balancer can help you by kind of sending session stickiness and things like that. But that might help you for sessions if you have image or file uploads or any sort of, you're saving stuff locally on the server based on user, whatever the user is doing. You're going to run into problems. So obviously, you should do from the beginning. You design your entire app, not to rely on anything on the server. I guess you have to design as well with, if you have multiple servers, and as far as deployment goes, it's not just multiple servers in order to maintain, for scaling purposes, for transaction count. It's more for being able to maintain multiple live versions live at the same time, to go back and forth between them. But also you could have a load balancer with multiple versions of code behind that load balancer, and there was no adverse effect. So obviously you want to, add columns, but you don't want to rename or remove columns that are not in all live versions. So if you have to rename or remove, you have to kind of stage those, and you have to do different things, different patterns to deal with that. But this is just one example. All types of changes cannot be breaking across live versions. So once you solve that, if we go back, we solve the problem of, single point of failure and the service is down for X seconds. But if we go back to, our service is still partially down for X seconds, because until the load balancer kind of redirects the traffic, if you publish, you have two, three, four, it doesn't matter, but then traffic is being split between them. If you publish to one of those servers, that server goes down for the same amount of seconds back in stage one, but this time there are other servers to pick up, and after X number of seconds, your load balancer will realize that it's down and redirect the traffic. You still have untestable deployment. And again, here if deployment fails, you're not as bad as before, you're not down, but your capacity is degraded until again you fix or revert to previous version and then redeploy. So we did accomplish some stuff here. So now let's solve the kind of the partially down problem. You don't want even one request to fail, whether it's a transaction or whatever your your application or API is doing. So here's a pattern you could use, but pattern that I've personally used, but your mileage may vary. So you go to the load balancer and whatever service you're using, and you remove the server, one of your X servers or N servers from the load balancer. You wait till traffic bleeds. You deploy to that server. You wait again till deployment's finished. You add the server. You can do some sort of testing there, actually, but you add the server back to the load balancer. You wait and kind of rinse and repeat for every server you have, and you kind of one at a time bring them up to the latest version. And again, so you're serving traffic to two different versions of code, and that's important to be able to do that. Session management is not on servers, so you're not adversely affected from this type of situation. So now we kind of improved our stance, but we still have lengthy deployments. Right, your order of growth is n, depends how many servers you are, okay? You have to repeat that process for n number of servers. You have now degraded capacity during deployment because you usually have a capacity of called 4 servers. Now you only have 3 at a time. So you have slightly degraded the capacity, or sometimes from 2 to 1 is 50% less. You still have kind of untestable deployment, but which we'll get to in a moment. And now if deployment fails, again, you still have that degraded capacity. You still have 3, let's say from 4 to 3 or whatever. You're down X% in capacity. While you fix your Revert part, you have a little breathing space to redeploy to that, to that server that's, if the deployment went sour. So now, we kind of hinted to this, but to solve the untestable deployment, and to do it a little more at scale, and especially when you're using, EC2 groups that are, that once you're using a load balancer, usually you're not accessing the server directly. That's kind of why this pattern is here, as opposed to just testing the servers manually. So this would be a pattern that all your servers behind load balancer, you can't even access them. You can't even access them directly. And now you want to, so you kind of have these 2 load balancers, LB1 and LB2. And let's say you have 4 servers in LB1. You remove a server, you add it to LB2 so you could hit it. You wait till traffic bleeds off really from LB1. And you deploy to the server, you wait till it's live. You test on an LB2, then you remove it from LB2, add it back to LB1. You wait till now, traffic starts going into LB1, and then you start again, you bleed off another server, rinse and repeat. So this gets you to a stage that, you can test, but if you're doing this for each server one at a time, you still have your lengthy deployment, still got to repeat it for n instances. You still have degraded capacity during deployment. Now you're testing, you can do, but it's still lengthy, testing 1 server at a time. If you choose to do multiple, then your capacity, if you choose to do half of them, then your capacity goes to 50%, which might not be, you have that would be depending on your, what 50% means to you. So you do have to break it up into chunks, as much capacity as you're willing to give up. And again, if the deployment fails, you're still in the same spot. So now this is a little, solving the fix revert. On this, the degraded capacity is really until you fix the problem or revert your code to previous known good version, kind of redeploy. And so we'll just solve that. Sorry, I'm going the wrong direction. By compiling, building, kind of storing your artifact wherever, whatever cloud or artifactory you're using. And then when you deploy, you don't deploy from something that you just built. You deploy from a specific artifact. When you go to your next version, you note what, or you know what your good version is before you go into your deployment. And if anything goes wrong, you just grab that version and just redeploy it. So you don't have to kind of rebuild, recompile, because who knows what could happen in the interim when you try to recompile. Doesn't always work. One interesting tidbit here is that we actually build into our compile build, we build in kind of the version number and like a date timestamp, and then our artifact gets that same kind of string, same version string when we store our artifact. So we can actually hit our API and know the version that's compiled into the API, and that'll be the same name. Like our CI/CD will bake in the version number into the code. So when you go to the API, you see the version number. This way, I can just hit any live server and know what version that live server is, and we have multiple regions and multiple live versions up and running all over the place, and we can tell what version that is, because if we redeploy to that stack, we can know what, what the previous version was and grab the right artifact. So it's an interesting tidbit to be able to look into your code and know what, look, if it's, if it's an API, or even if it's or website, you have some URL that will give away your, whether it's an internal, external, however you decide to protect it, or if it needs protection even, will give away your artifact ID, let's call it. Okay. So once we have that, we improved our stance slightly there. We still have our lengthy deployment. We still have degraded capacity during deployment, lengthy testing, but the bottom line improved that the degraded capacity is only until redeploy of an artifact, which can be done pretty efficiently, and can be deployed. So you can get back up to full capacity and then go fix your problem, and then come back and try again. So to solve the kind of the degraded capacity issue and the N problem, we can approach it, and again, especially in the cloud, much easier than on-prem or, on colos. But you can, if you double your server capacity, you have, let's say, 10 servers, so you double it to 20, put the 10 new ones on your second load balancer, wait till those 10 are there. You deploy to each server. Now, if you're using any sort of tooling that deploys to, all servers at once, that's problematic. And this, unless you can come up with some sort of tagging or some sort of other way to deploy to those 10, but you can't just deploy to a stack because your stack has 20 in it. So we'll talk about that. And again, there might be different patterns, but we'll talk about a pattern at the next stage. But you're still deploying to each server. So that's an N, but a very minute N. You wait. You test now on your stack of kind of LB2 has 10 servers behind it, which is your full capacity. You do your testing. You take the servers off LB2 and put them all LB1. So now you have 20 servers in LB1. And you wait till they start serving traffic. Then you remove your old servers from LB1, and now you have 10 brand new servers with your new code deployed to live, zero downtime. Then you terminate your old servers and you're back to 10. And those have your old code on it, and you're kind of back where you were. You never hit degraded capacity, and the testing and most of the stuff you did was not rinse and repeat. Yeah, we crossed that out. You were able to kind of move more efficiently to the amount of servers you have and get zero degradation in capacity. The only kind of issues we're left with, at least that we want to talk about, are you still have the N for every server deployment, and you still have lengthy rollback. In order to roll back, you got to do the whole thing in revert. You got to do the whole thing again. You got to double your server capacity again, deploy your old artifact, wait, deploy, blah blah blah. If this takes and testing and whatnot, if this takes 10 minutes, you're down for 10 minutes. So we want to solve those last two problems. And with that, we'll come up with a little pattern here. And this is, we will just give a little prefix here. Most blue-green that you will read about on AWS or anywhere, I've had a very hard time finding articles that discuss this particular blue-green. And maybe there's some fault in there. Maybe that's why I can't find any stuff on it, but we'll see what there is one fault in a minute. We'll get there, but there might be others. But a lot of blue-greens that describe really, if we don't go back to 2 steps, instead of doubling your server capacity, a lot of blue-green deployments will kind of will automate kind of they'll deploy to 1 or 2 servers, put them into traffic, give 10% traffic there, and kind of will rinse and repeat for you, and slowly shift from blue to green, and slowly shift over your servers. And that's fine. That's another pattern on this. You still need, if you want to roll back, you solve on kind of the single server deployment, because they kind of take care of that for you. They take care of the deploying to each server as it pops up. but it doesn't, the lengthy rollback you still have to reverse that unless you're willing to go cold turkey and push it out entirely because you have an issue, which you could have done even without the kind of a blue-green. Going back to this, if you have to redeploy and you say, listen, we're down, I'm not going to wait to do this all. I'll just push the old artifact in on the existing servers. We'll go down for 10 seconds, whatever. And, so you could, depending on what the issue is, but if it's a very, just a little bug in code affecting a small subset of merchants, you still want to go at it properly. So you still have a lengthy rollback. So now let's try to describe our, the blue-green that kind of we use. So we'll have two separate server stacks, totally independent. Each one has its own permission stack, its own roles, its own everything. There's no interdependency between the server stacks. The only kind of point of failure, single point of failure at this whole level would be the load balancer, which is usually going to be a cloud service provider, the cloud service provider, AWS or whoever is going to be taking care of that for you. So you have no single point of failure that you own. Two entirely separate stacks, we'll call them blue and green. Blue is live. You deploy to green using, whatever instant deployment mechanism you do. All servers at once, half servers, however you want to deploy it, because green is not live. Green is on standby. And you can deploy to it, without any effective downtime. You wait till deployment's finished. You test on it, and now that your green stack is good. You take green and add it into your load balancer, the whole stack, either in ASG or a target group, however you move it in, and now you have kind of two stacks live. You wait till enough of your green servers are feeding traffic. Then you remove the blue stack, and your blue's sitting there on standby. If any issue arises, all you have to do is repeat in reverse the bottom three steps. That takes usually 30 seconds or less. So you can go from old version to new version, sometimes in 10 seconds. It's really, what takes the time is for your load balancer to just start serving the traffic to your new stack. It really takes a second to trigger it, and it could take 10, 15 seconds for the load balancer to register the new servers and start feeding them traffic. So you get to the point where you can really serve, cut over, deploy. So if we go back all the way to the beginning, and you're starting off, you probably deploy during the day. And then as soon as you had a few outages during the day and you already had enough people to complain about it, you learn and you do it at night. So you go down at night, and then eventually your usage at night doesn't afford the nighttime outages. So then, we today are serving a crazy amount of traffic to people who are waiting online in stores, websites, and whatnot. And it's obviously we have less traffic at night, like anything else, but there's nonstop traffic, and there's no downtime. We deploy today using this pattern. We deploy in the middle of the day, preferably a little earlier in the day, just so we have time to monitor. We try not to. We don't have any nighttime deployments, planned nighttime deployments, or we don't even deploy if people aren't in the office for another few hours, just to keep tabs and monitor and be able to roll back. So we're able to kind of deploy during business hours, during peak usage, without any adverse effects because of this pattern. The only problem with this pattern is double the cost. Unless you're willing to, while you're on standby, now if you publish once a week, now what do you do with your standby servers for that whole week? So you could lower them, then you risk, then you have to, part of the deployment process have to bring them up. Before you deploy, you got to bring them up. There's another benefit of having the second stack. that in case there's any issue in stack 1, blue or green, you have another stack on standby that can kind of quickly step in 10 to 30 seconds. If you need to wait a couple of minutes for it to depend, obviously this depends on what you consider high availability. So, but at the end of the day, there's 2x cost for a good portion of the time. You might be able to whittle down the 2x, the drop, by lowering, while it's on standby and you're stable for X amount of time. Because before you're stable for a couple of hours or even a day, you want to be able to, when if something gets reported, you want to be able to have that ability to just quickly revert. But so the cost is somewhere between 1x and 2x. So the way to solve that is to go serverless. And this, initially when we started with serverless, we weren't even thinking of blue-green because a lot of the serverless stuff kind of has versions built in, has a whole bunch of stuff built in that kind of help you have multiple versions. But what we realized, there's nothing replaces this concept of blue-green of separate stacks. We actually had an instance that where something wasn't yet fully blue-green on serverless, and we renamed an API gateway or something. I forgot the exact thing that we did, and when we deployed it, there was a bug in CloudFormation or whatever that just didn't wire up a resource properly, and it took us well over an hour to figure out that that's what it was. And in the meantime, we had no recourse, and we thought it was a bug in code. So we redeployed the previous version and went to this version, that version. We just kept on trying to figure out a version that would be good to go. And no matter what we did, we couldn't. So we tried fixing the problem. We couldn't go anywhere back or forward because there was a bug in the stack. It couldn't move. The only way to solve it would be we could have deleted the stack and redeployed the whole stack, or we'll kind of publish the stack without API gateway and then with API gateway, and then that forced to recreate. But it was like a bug in just how, within Amazon stuff. So that's kind of an unavoidable thing, and redeployment did not help. There was no way to fix the problem by redeploying. We had to kill the stack. Not always is that an option for everybody. That's another thing to keep in mind. In our deployment, we never mix what we call data and compute. Compute is stuff that you can recreate without any downtime, without any concern for losing data. And data is databases, S3, anything that if you recreate it, you'll lose information. Even a CloudFront you might lose if you lose the CloudFront ID, so now your DNS is pointing to the wrong place. And unless your DNS is wired up that way, you'll lose it. So even in serverless, where kind of there is this stuff built in, the benefit of having 2 separate stacks is amazing. Totally independent. One does not depend on the other. They talk to the same databases and the same data stack. That's another reason to split out compute and data. They'll talk to the same database layer or data layer, but they'll be totally separate on anything to do with compute. And the pattern here is like so much simpler because of serverless. 2 serverless stacks, you deploy it. Let's say blue is live, you deploy it to green, you test on green. And here, it's not like a load balancer. You could have load balancers maybe to point to serverless, but we usually have CDN pointing to it, and you just switch to origin and boom, you're done. We find this works wonders. Thank you for listening. Any questions?
Yeah. Who was able to unmute themselves? Okay.
Yeah, I have a question. How do you manage data access in your application, given that you potentially can have to roll back to a previous state of the application? In other words, if you add, let's say, a non-nullable piece of information to our relational database.
So we discussed that one of the way back right over here is one of the conditions just to live in any stage of this game. You need to make sure that you don't introduce breaking changes across all your live versions. So you can't, if you want to introduce nullable or a non-nullable field, you need to phase that in. You need to phase it in through your live versions. If it's 3 versions ago and you don't play, and if you have a version that's live for X number of days or weeks, whatever you decide is good for you, and now you're deploying a new one, as long as you don't have to be concerned with 2 times ago's version, because you don't plan on rolling back that far, but you have to introduce your change slowly. You cannot make breaking changes. That's just part of the design. So you have to engineer it.
What about breaking changes going the other way? So, for example, having the new code that you write assume that data isn't present on, let's say, a column that it adds.
Same exact. And let's say there's different patterns to deal with this. Let's say you want to use a new feature, and you can't think of a way to use the feature without having the old version not be aware of it. So you deploy a version that has all the code for the feature aware, but don't turn it on. You have a flag that keeps it off. Wait a week till this new version becomes the old version, all right? And then turn your feature on. Now your old and your new are aware of this feature. There's different patterns you can use, but you got to design to be able to at least X number. We have more than just 2 versions live because we're in multiple regions. So we'll have versions in 2 different regions, and each one will have a standby and a live. So we could have at any time a minimum of 4 versions live, quasi-live. That we want to be able to, between standby and live, we could have more than 2. But that'll depend on what you consider high availability. But that's in a nutshell. Is really you got to just design it that the previous version will be fine if it would. Think of it, it's behind the load balancer, and both versions are serving traffic. That's how you have to code it.
So I guess if I can ask one final follow-up question to that would be, do you have a way of enforcing that within your pipeline? So from my understanding from what you've been saying, that you have an automated way of doing this. Is part of that pipeline some way of enforcing this?
Yeah, I don't know. I mean, it's a good thought, and I'll give it some thought. If it's I don't know if there's a way to enforce that. No one. Let's say in our database changes, we have a way of enforcing that you don't, that you're switching from schema A to B, that you don't delete columns and do stuff like that. And it doesn't allow for renaming unless you're really, really explicit. It's just really it's a design concept. It's really like your code. I don't know if there's a way to enforce your code not to break. But one of the ways you're going to suffer immediately. I mean, it depending how when that change gets triggered, but you're going to have traffic like in this design in any stage of it. You're going to have traffic going to both servers at the same time. So you're going to get hit with that right away. So it's almost like like Chaos Monkey. You're gonna if you start doing that, you'll get hit right away with it. It's not going to crop up one day. Now, if you're today on a single server or not doing it in this pattern, you might have. But it's not. You don't have to fix any legacy. You just have to going forward. Just make sure all changes are aware of previous versions. So it's not like you have to, that part you don't have to fix. The external storage part that I'm pointing out here, you have to fix, stuff that you might have done. But this is not fixing backwards. It's really just going forward. You just got to do it differently.
All right, thanks. Just one idea I thought might work is if you ran, let's say, your test suite against a previous version of the code against the new database.
So
I don't know.
So one way of kind of doing this is like we go to before this whole blue-green, we first go to stage. Now our stage is production data. So at that point you're gonna, you might bring down production if you do if you make a schema change at that point. They're like you're not gonna be able to work. Like the workflow just won't work if you're if you're doing this, I mean, our stage goes to production data. So blue, green, and stage go to production data. QA dev will go to non-production data, you know. But our stage is meant at before, because we don't want to butcher. I didn't mention this kind of because it's not part of the high availability of the deployment piece, but you don't want to butcher even your standby. Your standby is a precious commodity that in case your live goes down, your standby is there for backup. You might have published an hour ago, you might need it, and someone wants to test stage and he's going to push it into your standby, or because that's where what stage of the game he's up to. You can't let that. If we actually if we have a bug fix, what we do is we'll reverse the blue green to what we just deployed. So now the old version is live. We'll republish to the new version, and then switch it back. This is where we have an old version to go, even though we still have those artifacts, and in let's say 2 minutes we can get up from an artifact, right? But we still want to have that standby there.
Thank you very much.
No problem.
I had a question. What do you think about the concept of canaries? Meaning adding a new green server, giving it 1% of traffic, watching the error graphs, and if everything's clear, then you deploy to push the CD into the rest. So
that we mentioned that kind of when we talked about a blue green at this potentially at this stage of the game, and that's how like classical blue green will use canaries and move traffic every 5 minutes, increase 10% or whatever pattern you could set it at. You could do that with this design if you make a few more target groups and like split out your servers. But we've found that again, we found this works well for us. As kind of as soon as we fully with standard canary, you're not testing your coding production. You're not testing those servers per se. Obviously, when production traffic hits it, there's no way to test that unless you have production traffic hit it, and canary is a good way to do that. But bleeding traffic to it, like DNS or even like shifting traffic, I don't know. I just couldn't shove it into this design, and the benefits of this design that I get to switch back very quickly. And we do a decent amount of testing before, a lot of automated like end-to-end tests on it. It gives us a comfort level going in. As soon as we deploy, like we monitor, any error logs and different dashboards that that will highlight if there's any issue, and we're very free to pull the trigger back. It doesn't cost anything to pull the trigger. So if there's any anomaly, boom, we'll pull the trigger. Again, if you can take this a step further, and the hard part about the canaries is they're two disparate stacks. And if you use maybe DNS to shift traffic, then you're running into DNS propagation problems, and it's much harder to recover. You're not getting 30-second, even if your DNS is 30 seconds. There's other problems. There's downline caches that don't listen. So if you come up with a good way of doing a canary with two separate stacks to shift the traffic in slowly, that would that's a potential way to do that. If your CDN could kind of use two origins and then move traffic over, you could get that. We've yet to see the feel the pain or need to do that.
Thank you.
So we're about to move to speed circles. Just before we do, Yanky, thank you so much for your talk. If people want to learn more or be in touch or find you online, how do they do that?
Guess you can always email me, Yanky@Cardknox.com.
Easiest way. Okay, great.
Don't have too much social media. I'm also on the From Dev Slack.
On the Slack.